se oye, Sonas.
Sí se les está permitiendo el paso, ingeniera.
Gracias.
Meanwhile, there's a friend of mine here. I don't know if Lee, you can hear me?
Yes, but just 1 second. Vladimir.
Excellent, Jose. And
Yeah.
Escucha eco.
¿No?
Yeah, but I was asking for a friend that I invited to the talk, that is Lee Cotterill. Bro, can you hear me?
Vladimir, I can hear you.
Okay,
I'm sure most people can hear it the same way I can, which is
okay.
It's a little noisy. So
I have the fan here. I don't know if that is producing some noise. I don't think so, because every time I give a lecture,
now it's better.
Yeah, I use the fan. There's no.
Yeah, now it's better. Okay.
Okay.
All right. So I have the job to introduce you right here. So
just give me a little minute, please. Just give me a little minute.
Okay. I will introduce you first, so you have some time to prepare.
Sí.
Okay.
Okay.
Okay. So we're good. Maria Angelica, okay?
Okay.
Okay, so we're going to start now. Good afternoon, everybody. Thanks for being here. And today I'm going to introduce Professor Vladimir Sánchez, who is a professor at our Faculty of Electrical and Computer Engineering, specifically at the Telematics Engineering program, where he teaches courses related actually to the talk that he's going to be given today. Today, Vladimir is going to talk about M2M technology for bus fleet management. And specifically, he's going to talk about a case study, which is the college transportation system, specifically for the Spoke campus, as I assume. And well, just briefly, I'm really excited for this talk, mostly because M2M technology is quite a new topic in telematics and in general in information technologies, and I'm pretty sure this is going to be a very interesting talk. I'm going to give a brief description, which also is included in the flyer for this talk. Vladimir today is going to talk about this project, in where he's going to describe this pilot plan, which is going to try to provide a real-time bus location for a college transportation system. So administrators can schedule routes based on travel criteria. He's going to present the reports that are generated by the system, which include bus locations, and all these reports and data is stored in a server, which helps us to analyze routes and to plan and manage path options for the buses. So without ado, please, everybody, welcome Vladimir. Professor Vladimir Sánchez, and you can start, Vladimir.
Thank you very much, Jose, for your words, for your introduction. Thanks to all the attendees for being here. I'm going to share my screen. I think it's not, please, can you tell me if you can see the presentation mode here?
Yes.
Okay, I'm now in the presentation mode. I'm going to start. Well, as Dr. Cordova mentioned, I'm going to present the M2M technology for bus fleet management in the case study, a college transportation system. This work was presented in the TENSCOM 2020 on June, and it's part of the series of conferences that the Technology and Engineering Management Society of the IEEE presents every year. Here we have a background where we know that colleges around the world are not necessarily located in midtowns or downtowns, so they can be far apart, far away from this area. And that presents as a challenge for the administrators of the ground transportation system. So they have the necessity to assure that the staff, students, lecturers, and visitors can have access or to the facilities to the college in order that they can do their different activities. So as a background, I can say to schedule routes for optimizing vehicular availability, to know about the monitoring of the passenger demand, and to prevent delays. Then we have several problems, such as the issues regarding bus tracking, also the delays in the delays can affect the users, and higher traveling times are experiencing, especially from one point to other because of these delays. The purpose of the project, we have three defined. First one, to set a network using machine-to-machine M2M technology for solving logistic issues that passengers experience in transportation services into or outside the college. Second, to inform about location by data provided through a telelog for analyzing the bus information for service enhancement. The third one would be to set geolocation devices in college buses for communication between a data management platform and a web server through a mobile network. Objective, we defined a main one, that is to implement a network based on M2M for optimizing the management, planning, and supervision of a college transport system by real-time tracking solutions. Three specific, such as to design M2M topology support through a mobile operator network, to develop a real-time visualization system for end users using TV monitors, and to assess the proposal by the monitoring of an operating road. The methodology for the specific ones will be, for the first one, deploy M2M resources with the adequate assignment of exclusive IP addressing that is going to be in the SIM cards that are going to be located at the same time in the buses by a geolocation device. Also, we need to assure that the security policies are going to be well established in the firewall for protection of the network. And at the same time, we're going to achieve this through an exclusive internet channel. For the second objective, we are going to have an application configuration in order that we can manage the real-time location of the fleet. And the third objective comes as the end-to-end connectivity with a local mobile operator in order that we can configure a server with internet access to store information from the behavior that we are monitoring of the buses. Expect results. Users from the transport service will have a visualization of the location of buses in real time. Then the proposal will allow the administrators to manage the routes, their arrival times, and plan possible updating. The connectivity of the transport units to the MPLS network of the mobile operator. Sorry. Here we have a generic topology where you can see three components. In this scenario, I can mention that the sending and receiving of data could be achieved between the software management and the application unit of the OBU, the onboard unit, through two approaches. Could be through mobile networks and also through vehicular ad hoc networks, the banding networks using or supported by Wi-Fi, infrared, or CB. The first one, the first approach is going to be effective if we have an active connectivity through a service provider, but the second one needs additional infrastructure. The banding network needs, for example, the roadside units, the RSU, in order that we can measure or can obtain the parameters necessary to do the monitoring, but this additional infrastructure is composed or is located in sidewalks, parking lots, markets, streets, among others. And also we need to use shared coverage transmission devices to measure or to know about the positioning of the devices that are passing next to them. Here we can see that the connectivity is going to be in a bidirectional way that is necessary to avoid potential interferences. And at the same time, maybe radio links are very useful in this case because we can assure the interoperability of low power consumption devices that manage bursting and intermittence, especially if we have a congested scenario. And then we have the vehicle as the first component. We can mention the vehicle, where it's going to be set the geolocation device, as you can see here. But the vehicle needs to have the electronic control model, the ECM, known as the vehicle brain, in order that we can connect the OBD port, the onboard diagnostic port, to the geo device, to this device. So, and then after that, we can have the connectivity, and we have here a data platform as a server that can storage the information. Sorry. And then we have the application where the administrator can do the necessary configurations according to the routes and the monitoring required. I can mention also that here, if we don't have the available ECM in a bus, we can connect directly the device to the battery of the vehicle. And that is an advantage because also we are not going to take care about the battery lifetime issues. I can also add here that this device, the Geo device, sorry, here, the Geo device has a GPS receiver and also have a cellular modem that is very useful, especially if we would like to do accurate tracking of the vehicles, and also to have additional information of the behavior of the bus. Here we have the system architecture. Well, we have a mobile operator that provides us internet, and we have two links. The one consisted of fiber link, a fiber optic link that was about 1100 meters. And the second one was a radio link of 23 gigahertz that was the nearest position between the provider and our facilities was almost 3 kilometers. We have the necessary connectivity in order that we can use a CPE, a customer premise equipment that is based on a Cisco router that has the capacity of 1 megabits per second, which is necessary to do the communication with our server. Here, as I mentioned before, we set the security policies necessary to protect our network, to protect our storage data. So at the same time, this CPE is also necessary to connect the SIM card to a specific access point domain based on the mobile operator, and with the interoperability of the Internet Mobile Subscriber Identity, we can have either private or public addressing. How can we realize about the data that we are having? The proposal includes a TV screen that could be located in the bus stations, and it's going to be very useful for the end users, and it's going to be at the bus stops, as I mentioned. But the connectivity will be guaranteed with a computer stick, with a Wi-Fi module, and also we need to consider that we need to use screens that obeys to the IP65 certification in order we have to avoid dust, water, or another environmental conditions. For the use that we have, for example, for students, we can have the bus location in order that they can have the estimation arrival time. And also we have the publicity. It could be commercial in case the university needs funding, but also could be information about the events that the university is going to hold in some moment, maybe it's going to have at some moment, regarding to webinars, conference symposiums, among others. And the administrators, they have all these parameters to configure, but I can remark something here. The application was very friendly, and we thought that it was very useful in case that the administrators don't have the necessary knowledge in computer systems or informatics. So it will prevent us from any setback regarding the configurations. So that was one point in favor of the proposal. Here we have the fiber optic feasibility. As we saw in the previous slide, we had a path of 1,100 meters approximately. We didn't have any problems with this. The provider supported that in aerial fiber optic, 6 fiber. And then we have the radio link. We used the 23 gigahertz license spectrum because we didn't have available, for example, a WiMAX connectivity or Wi-Fi open free connection. And we supported in the UMTS network of the provider. And here we are sure that we obey the 60% clearance recommendable by the Fresnel zone. And this was not any problem at all. Here we have a screen regarding the system administrator that, according to several menus, several options that the administrators could have in the menu, they can do the appropriate configurations. Regarding to the testing, as you can see in the bottom, we have set in a specific path that is located here in red dot, in red lines, with the maximum speed of 30 kilometers per hour. But what happened in that red line? It was detected that the driver speed at 53 kilometers per hour, and that is an alert that the administrator will follow. Here we have another example about the depiction of the speeding, and also we have a screen here very useful for the administrators according to the menus that they could have, and they can set the adequate path and the adequate speed according to this path. But we have to remember that in case that the driver is not respecting the path or the speeding, it will send an alert to the administrator, to the system. Speed profiles, we have here an example of a 1 hour period where we can measure different speeds in this timeline, where the red lines prevent us that there was speeding, and the other ones could be mentioned as alerts or transitions. So if the administrator wants to follow up this situation, they can choose or they can pick a specific timeline to analyze more. Well, related work, we have the safety pilot model deployment that was elaborated by the Transportation Research Institute of the University of Michigan, which consisted in a fleet of 2,800 vehicles, such as cars and trucks, in order to know the prediction of crash avoidance and traffic flow. But this proposal was complemented with B2B and B2I technology. We have the Picasso project that was a collaboration between the US government and the European Union. This project was to know about several challenges that could afford the M2M technologies in traffic. Then we have the companion project that was a true platooning initiative to know about the carbon footprint that trucks emits to the environment. Finally, we have the Carnegie Mellon project that was collaborated together with the University of Aveiro and the University of Porto, which consist in know about the behavior of a taxi fleet, to know the experience satisfaction. All of these projects were based on M2M with some complements, as I mentioned before, with B2B or B2I. Conclusions. Communication via GPRS technology was obtained for multiple monitoring and remote management options. Well, even though this is a proprietary case, this applies to scenarios of more ground coverage and a higher density population by either AP interface management or open source programming. At the same time, the proposal depicts that a well-planned transport system allows to show information regarding frequencies, bus stop routes, and detours. I can mention something here as part of the results. When the drivers were aware about the monitoring, they drove in a better way, and they respect most of the time the rules, the transit rules, and also that was we know by this project we learned the know-how of the system for a second stage and a third stage. The second stage consists in a proposal for a device that is going to measure parameters regarding to that an engine, a motor can provide us. That is going to be is a collaboration with Professor Ponguillo, and I hope that that research will have the experiments done. But we expect that that collaboration comes out maybe on between February and March. And also a third stage could be the application. The application that is going to be developed with Professor Coyahuaso, and that would be the third stage completed. Thank you for your attention. If you have any questions, please be my guest. You can use the mic. You can use the microphone. Thank you very much for your attendance.
Yeah, I have a quick question, and forgive me if this is a stupid question. What is the advantage of having a regular GPS as opposed to M2M? I know that with M2M, we would be able to read some parameters from the bus itself. But if we use a regular GPS, is there any advantage or disadvantage with M2M?
It depends in the case that we are deploying, because we know that not every regulatory domain has available all the technologies. This was an approach to know, or as I mentioned, to learn the know-how of a monitoring system. But I would say that it depends a lot, and I don't think that there is a complete advantage or maybe disadvantage using A or B technology. But in this case, it's what we have available at the moment, is what the provider provided us, and also we are attaining to monitoring the behavior of the driver, the buses. So I would say there is not so many advantages, but it depends on what technology you have available at the moment. For example, in Ecuador, we have widespread the 3D technology that is an advantage for us, even for rural areas. In case, for example, the bus has to go far away from the city for some visiting or similar. And as I said, it depends on what you have at the moment.
Okay, thank you. Another question is like, I see you're using a radio link between some areas. And are you sending that signal encrypted, or is there any sort of protection against hackers that can change the information that is being transmitted?
Okay, good question. That information is protected by the mobile operator. I will return, sorry, let me return to that slide where you can see here. This part was from the service provider. So in this case, the service provider gave me all the facilities, including the security of the network. But we need to assure the protection of our network, in this case, in our facilities. So, well, it's an extended version. Here we have the considerations regarding the protection that we have to consider. We have to deal to our server, and this is the part that we manage. So, in order to to follow an order the mobile operator provided us.
So the protection is actually provided by the ISP, right?
Yeah, but until here, because we have our facility. And to be honest, the provider gave us the storage information in a data saver of their own. But it has one disadvantage, that we can only store, according to contract, 1 year period. So in that case, we need to develop our own server in our own facility, and that demands to follow a protection of that server. So this is the part that we are following in a third stage.
I understand. Thank you.
Okay, thank you. Any other question?
Good afternoon. Congratulations. Good work. Can you repeat this work in another institution, in another college?
Yeah. Thank you very much for that. To be honest, well, we would like to do agreements between the Sport Polytechnic University and other municipalities of Ecuador, because we need funding. I think that is something that we require. But I have a friend, it's not here in the talk, I think, but I have a friend that is an engineer that is operating in the province of Santa Elena, that is in the coast of Ecuador, and he was very interested in this project because this is a first step in order that the cities of that province can approach to a smart city focus. So he was very interested. He wanted to present this proposal to a municipality as a first presentation, but there was an issue that because of the pandemic, we couldn't do a progression of this, but it's pending. Yeah, we are trying to approach to other municipalities. And we can, as I mentioned, this is very useful if we want to approach to the focus of smart cities. We know that smart cities are very attractive for visitors, for businessmen, for business visitors, and for tourism especially. So I think the concept of a smart city could be approached with this type of proposals.
Thank you.
Okay, thank you. Any other question, please? If you have any other question, please don't be shy. We're here to learn and also to propose. You want me to continue sharing the screen? If you have any question, please be my guest.
Excuse me, one more question. I don't know if the municipio of Guayaquil has a system that uses the same technology. I don't know if it does. If that is the case, can you join your implementation with them?
Yeah, a good point. We know that, well, the municipality of Guayaquil is kind of closed. They are not so wide open regarding to the information they can provide about their technologies that are implementing. But we know that this system is similar to the one that Metrovia is using for the users to know about the estimating arrival time of their units in their different bus stops. But project was made in 2018, 2017 and 2018. So we have been delayed concerning that. So at that moment was also the deployment of the Metrovia system with a similar proposal, but we are not so sure if they use the same parameters, for example, similar to this one. Okay, we don't know what kind of link they are using, for example, for as a main link or as a backup link. We don't know exactly that because they are not so wide open. It's kind of difficult, maybe you can know about this, to approach to big municipalities. That is why we tried to approach to small ones.
Thank you.
Okay, thank you. Can you listen to me? Because I have problems here. Okay. Any other question?
So I have a quick question. So for I see you're going to have a plan with your internet access for this. So obviously you're not going to be using the this bus system every hour. In terms of money-wise, right? So do you have to get a plan with the ISP for? You're not going to have 24 hours using this system, right? So, or weekends, you're not going to use it at all, or maybe partially. Do you have to have a plan with the ISP, or it's going to be running 24/7?
No, good question. In this case, the provider gave us the possibility to run 24/7 because for the bus transportation system, in the college especially, we can also use this bus system to do visit, for example, also to some communities for outreach projects. So we are not only operating from Monday to Friday, we also need the weekends. And it's 24/7. The cost was not so considerable. It was the part of the proposal cost like $8,000 per year, and no more than that. It's very convenient, and I think that the advantage of this type of proposal is that also we can monitor several other parameters that maybe are not presented here. We focus here in the speed. But for example, with this device, according to the programmation you do, to the configuration, you can also monitor the engine temperature. And that is a necessary parameter if we want to have the correct maintenance in the vehicles. Also, and that is part of the second stage that I mentioned that is it's going to be running through this month with Professor Pomillo, because we want to develop our own systems with our own devices. So this is part of the development that we are trying to pursue. But for us, it's ideal to run 24/7. We have several activities during the weekends also, even in the evenings.
Okay, thank you very much.
Okay, thank you. Any other question? Well, if you want to I am seeing in the chat, if you want to ask by the microphone, could be better because I cannot read so well. I don't have glasses, but I have to check. Okay, I am reading. Have you checked the transit, the transit agency of Ecuador? Have to check. Yeah, okay. At the time we developed this proposal, we didn't deem the aspects that the transit agent, the National Transit Agency, recommended because, as I mentioned, it's kind of difficult to approach to institutions, especially public institutions. But maybe this could be an option for the National Transit Agency to know more about the bus fleet, because this could integrate also parameters regarding to surveillance, and that is something that we also want to pursue, the surveillance of the vehicle, the inside the vehicle or outside. So I think that could be a good approach if we want to go ahead with the proposal. I don't know, please, Jorge, if that is a good answer for you. Sorry, I cannot read. Yeah, you are writing with capital letters. Is right. At some point, as I mentioned, an engineer that has a service as an internet service provider in another province of Ecuador is trying to reach this, but maybe the proposal it's kind of difficult to implement in bigger municipalities. That is why we thought that if we approach the small ones, maybe we can provide an example of how these proposals could work according to the different parameters. As I mentioned, we can follow up operational parameters, such as the engine, such as the surveillance, and also, well, the monitoring in real time of the fleet. Yeah. Yeah. Okay, thank you very much, Jorge. Someone else? Okay, the private company, sorry, Jorge, please be my guest. If you want to use the microphone, I cannot read so well. I don't have glasses. So, the private company that developed the systems. Okay, excellent. I3 Innovation Director, excellent. Well received. We can talk about that maybe in another conversation. I can provide you my mobile and also my email. It would be excellent, and maybe we have a scenario where we can do the testing of the second and the third stage that I was mentioning. Yeah, thank you. Could be good. Yeah, I know also Guido is an excellent professional. You're meaning the I3 lab, I think. So yeah, you're meaning the I3 lab, I think. So it would be very convenient for us. Okay, Jorge, I don't know if that satisfies you about the question that you were having. Okay, thank you very much. Good approaches. Someone else? Someone else wants to the question?
Good afternoon.
Okay.
Congrats for the presentation.
Thank you very much.
I have a question. The mobile application is not published yet. It's in beta phase.
Sorry, the mobile application, you mean the solution is not published? Where? You mean in a paper?
In the app stores. The applications for the end user, the users of the transportation.
Excellent. That is a good question. we can see this type of proposals, well, in developing countries as well as in advanced countries, like the ones of North America. Especially this idea comes because when I was studying in the US, I remember that was an application that only provides parameters about the estimation, the arrival time estimation of the bus. But maybe if we develop our own devices, not only to realize about the speed or the estimation arrival time, maybe we can know as users aspects regarding pollution that the vehicle emits issues. So in that case, maybe we can be so more responsible with the society, and we can ask our authorities to control in a better way the fleet. Okay. I think the things that you download from app stores and similars are kind of limited, but we are trying to pursue more. And this is the first step. I hope the first of several ones to improve systems that are going to be very useful for us, and especially if we have done the benchmarking, the necessary benchmarking, to develop our own devices, our own technology. Is I don't know, Miguel, is that good for you?
Yes, thanks.
Okay, thank you very much, Miguel. Please, if you can use the microphone, would be better. I can see that there is a chat. Okay, excellent. Yes, the paper came out as based on the thesis proposal. I can share that with you, as I mentioned. Let me write down here my email. You can get some connectivity. You can write me an email, and I can provide you the information. But remember, this was developed between 2017 and 2018. So, and also for the pandemic, we are kind of delaying this, and also other proposals. Okay, we are experiencing harsh times right now. Okay, okay, excellent. Please write me. Write me as possible, as soon as possible. Someone else? I don't know if someone else has another question. Please, or maybe Engineer Romo can proceed with the following part of the presentation. Okay, I'm going to stop the presentation mode. Could that be possible? Engineer Romo, could that be possible? Or should I continue with the sharing?
Hello, thank you for your presentation, Engineer Vladimir. So as we usually do in this kind of conference, we take a group photo. So please, the participants can turn on their webcams for the group photo for our social network.
Should I stop sharing the screen or not?
Yes, please. Thank you.
Okay. I cannot see everybody. Okay, I can see right now.
We invite our participants to turn on their webcams.
Only Sarah turning it on. Okay,
Don't be shy.
Don't be shy. we're here to learn and to propose. That is something that I always mention in class.
We wait for more participants, please. We're expecting more people.
Professor
Thank you very
Bonillo,
much.
Professor Bonillo, is there?
Okay. We take the photo. So we count of 1, 2, 3. Smile. Thank you very much, everyone.
Okay, thank you very much. Okay, that will be all. Thank you to all of you for your participation. It was my pleasure.
Thank you, sir.
Thank you very much.
Thank you.
Thank you.
Thank you, teacher.
Thank you.
Well,